All right, so there is a part 2 to this section. For one, this one focuses a little bit differently on not just straightforward integrals here. So it says the most general form of the solution to a differential equation is called a particular solution. Particular solution. The initial condition, so the initial condition is the value of y equals f of x for one value of x. So if you are asked to get the particular solution, that is basically you are finding C. So think of it that way. You're finding C. If you're asked to get the initial condition, that's the original equation. And typically you're asked to get both of them in the questions. So it says find the general solution of f prime of x equals 1 over x. So that's the derivative. And find the particular solution. So we're finding two things, general solution and particular solution. So I have to integrate f prime of x to get my f of x. So I'm going to integrate 1 over x squared. But before I do that, I've got to move that 2 up. Okay, so what I'm going to do now is I'm going to add 1 to my exponent. That same number goes in the denominator. And I get x to the negative 1 over negative 1 plus c. So that means f of x, when I simplify, is negative 1 over x plus c. Now I have to solve for c. Okay, so what it's telling me is saying that f of 1 equals 0. Well, if here's my f of x, that means everywhere there's an x, I can replace that with 1 and set it equal to 0. So negative 1 plus c is 0, which means c is positive 1. So particular solution, I'm going to just give that a PS. And then my actual general equation here is negative 1 over x plus 1. So this is your general solution or initial condition. All right, so we found both. All right, now for the second one, we're going to take our physics stuff. And we're going to work our way backwards. Now, some of you, since we know the formulas, there are shortcuts, but I want you to be able to show process-wise in terms of what we're doing here, using integration, not using anything else. So you got to use integration. So it says a ball is thrown upwards with an initial velocity of 64 feet per second with an initial height of 80 feet. All right, so that means the position at 0 is 80 feet. So that's my initial height. When I take the derivative of position at time 0, that's my initial velocity, which is 64 feet per second. So that's my initial velocity. And given that I'm talking feet per second, I know that my acceleration is going to be negative 32 feet per second squared. So that's my acceleration due to gravity. All right, so if I integrate, I can actually write it this way too. So here's velocity. If I integrate acceleration, that's going to get me velocity because I'm going backwards. Okay, so I'm going to integrate my negative 32. And now keep in mind, my equation falls into the t format because it doesn't have an x in it. It has t's. So when I integrate negative 32, that's negative 32t plus, I'm going to call it constant 1. So this is equal to my velocity equation. But I know that my velocity is equal to 64. Now, that means at time 0, it equals 64. So I'm going to sub in 0 for t. All right, which means that C1 equals 64. So my velocity equation is negative 32t plus 64. So I need to find the position function given the height, and I need to find when the ball hits the ground. So before anything, let me find position. Now if I integrate velocity, that's going to get me position. So I'm going to integrate negative 32t plus 64 dt. And I end up with negative 32t squared over 2 plus 64t plus c2 now. So this is my s of t. But I know that at 0, if I simplify this, Everywhere I put a t, I have a 0. I know that this value equals 80. So that means C2 is equal to 80. So part A to this, my function for S of t is negative 16t squared plus 64t plus 80. And I'm going to say feet. So that's my A. For B, when does the ball hit the ground? Well, the ball hits the ground when the position is equal to 0, not when t is equal to 0. So I'm going to take the function that we just had, set that equal to 0. I get lucky because they're all divisible by negative 16. And I get t minus 5, t plus 1. So I get 2 times 5 and negative 1, but I can't have a negative time. So it's going to take 5 seconds for this ball to hit the ground. So you have both the physics stuff back, and then most of the stuff is going to focus for right now. It's going to focus on particular solutions and initial conditions. So just remember